Hello, we are the Cervical Cancer Predictors group, Chris Andersen, Kyla Hirigoyen, and Nathan Wallace. We are part of the Department of Biomedical Engineering here at the U.
In 2022, 350,000 women died of cervical cancer, making it the fourth deadliest cancer in women worldwide. 94% of cervical cancer deaths occur in low-resource areas, especially sub-Saharan Africa. A predictive risk model based off of survey questions would allow clinicians to reduce screening of women at low risk and focus resources on higher risk patients. This could ultimately result in more lives saved. Our objective is to determine which risk factors are the strongest predictors of cervical cancer and to try to create an effective predictive model.
The data was collected from 858 patients that participated. There are 28 risk factors, 4 diagnoses, and 4 examinations. We were able to directly download the dataset as a CSV file from UC Irvine Machine Learning Repository.
Patients who provided their information were de-identified per HIPAA. For groups 2 through 4, we recommend that our model not be used for triage due to the limited data. With these ethical considerations in mind, we have decided to continue on with our project.
There was a lot of missing data in our dataset that needed to be dealt with. We only need 1 dependent variable, but currently have 4. There are 2 columns that are almost entirely missing data that we removed. The column DX was also removed because there is no indicator of its meaning. Patients who chose not to state if they ever had an STT did not undergo further questions about specific STDs. We have removed the rows with the missing values in the STD column to effectively remove these rows. Because there is very little missing data left, we decided that mean imputation of these missing values would not bias our results more than acceptable. We created a risk column by grouping HPV, CIN, and cancer as 1, 2, and 3 respectively, with none as 0. We then removed the diagnoses columns.
We made a correlation matrix to look for multicollinearities. There were 2 variables that showed no values for correlations. We determined that these variables had the same value for every patient, so we excluded them. We then identified 3 variables with lots of collinearities, which we then decided to exclude. This then leaves us with our highest collinearity as 0.75 indicated by the arrow. We used the OLS command from the stats model package to run our regression. The model wasn't very effective as seen from the R-squared value. We decided to iterate by removing the 3 least significant predictors from each iteration, their significance being determined by their p-value. We continued iterating until we had no remaining insignificant predictors. However, the model never reached a decent R-squared value.
The logistic regression model showed 96.7% accuracy, but the confusion matrix revealed issues. The model misclassified 1 patient with risk equal 3 and 4 with high severity as risk equal 0. In conclusion, we have determined that both of these models are poor predictors of cervical cancer. This is probably due to our limited dataset. If we were to have a larger dataset between more hospitals with a larger variety of risk severity, we would be able to create a better model.